I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you want.
So let's just do 2 questions or 3 questions. So let's start with number 8, then we do number 10. Number 8 says impedance Z1, Z2 are connected in parallel. This parallel group is connected in series of impedance that if the voltage across the parallel group is 50 volts, calculate the voltage across impedance 1. Here is what number 8 says. Impedance is Z1, right? Which is equals to a resistor and a capacitor. Is 6 and 6. It's connected in parallel with Z2, which is 4 and 8. Right? This is ohms, that's ohms, that's ohms, that's ohms. It's connected in series with impedance Z3, which is 10 and 9, right? Which is 10 ohms. And here you've got 9 ohms. And then the same, if the voltage across the parallel group is 50 volts, right? Calculate the voltage across impedance Z3. So they're saying the voltage here is 50 volts, right? Now, calculate the voltage across this impedance. So they want us to calculate the voltage that is flowing through here. Now I'm saying this question is easy. So let's talk about how we do this question. If you guys want to do it, let's talk about how you do it. So here's the trick, right? Here's the trick. I don't want you guys to focus on these. Let's just do this question anyways. I don't want you guys to focus on these impedances. These are complex numbers. I want you to focus on this as resistors only, right? So let me redraw it. So I want you to focus on it like this. Resistor number 1, resistor number 2, and resistor number 3 like this, right? Now, the voltage across this resistance is 50 volts. And calculate the voltage across that resistance. So this is how I want you to think of it in this way. Now, isn't this easier than that?
The second one is much.
The second one is much easier, right? Because you're all familiar with this. But it's the exact same principle. So let's talk about this in just 2 seconds. Now, let's look at the rules of circuits that you know, right? In parallel, does the voltage change?
In parallel, the voltage is the same.
The voltage is the same, right? That means voltage across Z1, right, is the same voltage across Z2. Are we together, right? Now let's look at another rule as well, right? Current flowing here and current flowing here, they all join to form the current that is flowing through there. Are we together? Yeah. So let's call this one I1, let's call this one I1, let's call this one I2, let's call this one I3. Are we together? Now, is this starting to make sense where we're going with this now, right? Now, that means that this current flowing here plus this current flowing here is equals to that current flowing there. Are we together? Now, the question wants us to calculate this voltage. So, what formula do we use to calculate voltage? Voltage is equals to? I times R. Are we together? There you've got your answer. What do you guys think? Would this question be extra difficult? Let's just do it. Let's just do it. So, if you are confronted with a question like this, forget this. Look at it in terms of resistors, because the resistors are 20 times easier, right? And then let's sort it out. So this is always my preference, right? I always prefer starting like this. Z1 is equals to 6. That's a capacitor, so that will be minus J6. Can you convert that part for me into into polar form? You know, I can do the first part with my head.
It's 8,485.
8, I was wrong. 485.
At an angle of
Negative 45, right? And let's do Z2. Z2 is 4 plus J8.
8,
Well, you've done this exercise before.
no,
Did you get the correct answer? Or you just did it now? Now, what did you get? 8,
944.
944. At an angle of
63,43.
63,43, right? So this is our Z1 and that is our Z2. Now our Z1 and our Z2 are connected in parallel, right? So that means Z1 times Z2 all over. No, sorry. There's no need for us to do this. Sorry. There's no need for us to do this at all. Because we are looking for resistance for the voltage here. So that means we have to get this current and this current. Right? So let's call this one I1, right? Let's call the current flowing through here I1. And let's call the current flowing here I2, right? And let's call this current I3. Are we together, right? So let us calculate the value for I1. We know that current according to Ohm's law is equals to, you would multiply the two.
V over R.
V over I. V over
R.
R, right? But then this is complex number, so it's V over
Z.
Z, right? So our voltage is 50 at a power factor of 0, right? All of it is being divided by 8, 485, like the first one, 485, at an angle of negative 45. And what do you get your answer as? Never let things that don't talk stress you out.
5,893.
5,893. At an angle of our angle will not be positive, right? Positive 45 amps. Now, can you convert this for me into rectangular form? Now, the reason why we're converting this into rectangular form, right, is because we're going to add it with I2. If we add it with I2, you add in rectangular form. Are we together?
X is 4,167.
4,167.
167.
And J is equals to?
4,167 is what? Why did they say?
So this is your current flowing through I1. Are we together? This is your I1. Now let's calculate our I2, right? Our I2 is equals to V over, let's call this Z1, and V over Z2, right? Which means it's going to be your voltage of 50 at an angle of 0 divided by our Z2, right? Which is 8,944 at an angle of 63,43. Don't you get close to the same answers? Your answer will be 5, something as well, right? 5,590. At an angle of, this one will now be negative, right? Negative 63,43. Now, if we convert this into rectangular form, what do we get? 2,500. That's minus or plus? Minus. 4,99 amps. Right. Okay. So now I1 plus I2 gives us I3. Are we together? So that's going to be I1. Now what I prefer is when whatever that you're doing, right, show it. So I'd rather prefer when you're answering a question like this in the final exam, draw a diagram. After you draw a diagram, now when you're calculating, make sure that everything that you're calculating is clearly visible. Are we together, right? So I want you to say I1 plus I2. This gives us I3, right? So in other words, this is 4,167 plus J 4,167 4,167 plus 2, that's 2,5. I can round that one up to 2,5 plus J. That one I can round that one up to 5, right? Can that one be rounded up to 5?
What?
This one.
Yeah.
For him, we can round it up to 5. Plus J 5. Now if we add in this 4,167 plus 5, you get 9,167. 2,5 plus 4,167, you get
667.
667. That is correct, right? This is supposed to be a plus. Okay, let's convert this into polar form. What do you get if you convert this into polar form? Now, at that part, we're close to done. So I3 is equals to, in polar form,
11,335.
Are you sure? It's 11.
Yes, and then the other one is 53,
Wait, 11,
11,335.
and that's plus, or that's plus. Also, that's an angle of
53,972.
972, right? Now let's do Z3, right? Now Z3, I should have just done it there, but I didn't think I would do it. Okay, so let's do Z3, right? Z3 is 10 plus J9, right? So let us convert this into polar form. What do we get? This is one of those topics that no matter what happens, you do this.
13,454.
13,454. At an angle of
4198.
4198, right?
98,98.
41,98. That is perfect. We know that. What did you get?
498.
And you know, did not even hear about it. I was just writing it blindly. Okay, so the question was this voltage here, and you know that voltage is equals to current multiplied by Z, right? And our current is equals to 13,454 at an angle of 40. That's not current, sorry, that's our Z, 41,98. All of it is being multiplied by 11,335 at an angle of 53,972. What do you get your answer as?
152,501.
501. And the angle is 41,98 plus 53,972. What do you get? The only thing that I'm not getting scared of is that they might present this differently.
95,9.
Yes?
95. 952.
952. This is our answer. Are we together, right? And our voltage is also in polar form. So that means we will say now our voltage is equal to, this is what I always prefer, right? You say 152,501, right? And you say at an angle of 95,952. Right? This is what I always prefer. And that's degrees. Are we together? What did the textbook get?
90.
90. The angle is 90 or the voltage is 90.
Oh, the voltage is 90,4.
Oh, there's another way of doing this. Let's see if that other way will give us the same answer. This way, that we multiply Z1 and Z2, then we get ZP. Then we divide 50 divided by ZP. We get an answer. Then that answer is the current that's flowing through here. Then we multiply that current to this. You guys have copied everything. This topic, no matter what happens, it will never kill me. So let's do it this way. Z1 times Z2 divided by Z1 plus Z2. That would be equals to, right? 8,485, right? That's an angle of negative 45. All of it is multiplied by Z2, which is 8,944. At an angle of 63,43, right? Everything is divided by, now this part is 6 minus J6 plus 4 plus J8. Now let's do it together. 8,485 multiplied by 8,944. What do you get your answer as?
75,889.
Mineras, what are you drinking? 75,
889.
889, right? 889. And the angle is going to be 45 minus 63. What do you get your answer as?
18,443.
18,43. Now, this is our top part. Now let's do the bottom part, right? 6 plus 4, you get? Minus 6 plus 8, you get? No, that will be plus 2. Okay, now let's convert this into polar form. What do you get your answer as?
10,198.
You get 10,
198.
at an angle of?
11,31.
Okay, so now let's do the division, right? 75,889 divided by 10,198. What do you get your answer as? If we get the same answer, there's something wrong with the text.
7,442.
Now let's do the angles, right? 18,43 minus 11,31. What do you get your answer as? You're actually correct. 7,112.
Yeah.
7,12, right? Now, this is our ZP. Are we together, right? Now, let us calculate the current flowing through ZP. Now, we should be able to get the same answer that we got there as I3. If we get the same answer, that means we're on track, right? If we get a different answer, that means somehow we made a mistake. We're not doing the calculations. So let's do IT, right? IT is equals to V over ZP, which is equals to 50 at an angle of 0 divided by 7,442 at an angle of 7,12. What do you get your answer? It's 50 divided by 7,442.
You get 6,71.
Is that the same answer we had before?
Nah. 6,719.
So this one is 6,
6,719.
19. That's an angle of negative 7,12, right? Now, can you convert this for me into, wait, never mind, this one is already defined the way it is. This one is already defined the way it is, amps. Okay, so let's do Z3, right? Z3 is equals to 10 plus J9. When you convert this into polar form, what do you get?
13,454.
13,454. That's an angle of
4198.
41,98. Okay, now let us calculate
987.
987, right? Now let us now calculate the voltage, right? I think hopefully this time, I don't think we made any mistake with the calculations this time. So let's see, we should be able to get the correct answer now. So we're now calculating voltage. You know voltage is equals to current multiplied by resistance, or current multiplied by impedance, right? And our current is equals to 6,719 at an angle of negative 7,12 multiplied by Z, we got 13,454 at an angle of 41,987. If you say 6,719 multiplied by 13,454, what do you get? I'm guessing 90.
6,719
It's 90.
Yeah,
Times
19,454.
times 13,
Wait, did you get it or are you getting me
Yeah,
from?
I get it. I got it.
Yes, 19,397.
7. Yeah.
What did the textbook get? That's an angle of
The textbook got 90,4.
that means they rounded off.
Yeah.
And now if we do our angles, what do we get? 41,987 minus 7,12. 34,867. Now, this is our answer. How come that one was wrong? Where did we make a mistake for the previous one? I don't think we made a mistake.